Hi, I'm Raj. I'm a PhD candidate from Georgia Tech, and I'm going to talk to you today about automated storytelling via causal common sense plot ordering. Okay, so now storytelling is one of the most natural forms of human communication, and just imagine how much more computers could do if they could tell stories, right? So this has been an AI grand challenge for quite some time now, mostly because it tackles many of the long-standing problems in AI. So, planning with language, causality, common sense reasoning, so on and so forth. So in this particular paper, we're going to tackle very specifically the problem of causal progression in stories. So now what this means is pretty simple, right? So the events in a story must sequentially and logically follow from the events that happened before, right? So take this example that you see on the screen here. In this particular example of Lord of the Rings, Frodo acquires the ring. He then travels to the volcano Mount Doom, and then he drops the ring into the lava, right? So there's this sort of like progression that you see here. So Frodo needs to have a ring, and the ring needs to be co-located with Frodo and at Mount Doom for it to be like dropped into the fire there, right? So now most sort of prior automated storytelling approaches for the sort of like causality subproblem use symbolic planning. So symbolic planning is nice and all, but it requires extensive manual knowledge engineering. And it turns out that we can actually make this process a good bit easier. And we're going to do this by treating the problem of story generation as plot filling. So all I mean by plot filling is that we're first going to extract very high-level plot points, so basically like the big idea, what the core of the story is going to be from some kind of source, and then elaborate or flesh it out until we get a full story. So we're going to do this by introducing the concept of soft causal relations. And the whole idea really behind this soft causal relations is that we're going to focus on the story from the perspective of a single character, right? What this lets us do is this lets us mediate the ideas of causality in this particular narrative via the reader's beliefs or expectations. So to really understand what it is that we're attempting to do here, we first need to understand, what exactly do I even mean by causal relations in general in narrative? Okay, so causal relations, right? So the sort of big idea here is that in order to go from these high-level plot points to sort of like all of the events that happen in a fully fleshed out story, we need to view causality as a set of dependencies that are framed in terms of enablement, right? So what is enablement? Enablement basically just means we're trying to figure out whether event X happens before event Y. That's all it is. So, this is actually basically the idea of causal relations in classical planning, right? So this first bit, of hard causal relations. So in this sort of scenario, you enumerate the kinds of dependencies that you need for an event to happen in order to figure out, what are so-called like illegal world state transitions. So basically this just means, John can't shoot Xavier unless, has a gun, they're within 100 feet of each other, depending on, how good of a shot John is, so on and so forth, right? But as you can imagine, the space of, possible world states here is combinatorially sized. And enumerating all of these, via manual knowledge engineering is going to get rather tedious really quickly. So what can we do about this? And to sort of help with this is when the idea of soft causal relations come into play, right? So soft causal relations are basically in which enablement is defined based on the common sense expectations of a single character in the world, right? So the common sense expectation bit here is sort of the key. So what it does is it lets us make assumptions about the world when we have sort of like no idea what the actual like illegal transitions are. So you're really relying on the reader's beliefs or the reader's sense, knowledge of what tropes are within this world. So, like the previous example here would be, in general, people seem to use weapons to fight. So I'm going to predict that, John probably needs a weapon to kill Xavier. So these are sort of like expectations that people have formed as they read many of these stories. Okay, so like I said before, we're going to do story generation as plot infilling, and basically this is going to occur in 2 phases. So the first bit is going to be, like I said, this high-level plot extraction. So we're going to extract the core idea of what like our story is going to be from some kind of source, and then we're going to flesh out this entire story, using this sort of like common sense reasoning into a low-level plot graph. So the first bit is plot extraction. So specifically when I say plot extraction, what we're doing here is we're going to take an entire story and we're going to try to extract the plot from a single character's perspective. So like I said, this idea of soft causal relations depends on the perspective of a single character. So there's a few parts to this. So the first bit of this is we're going to be extracting these sort of like subject relation object tuples using like an information extraction system from the story. And so these are sort of like, I guess, the condensed bullet points of what the story would be. And then we're going to use a neural co-reference model to sort of like, track a particular character's progression through time through the story. So, in this case, the particular character that we're tracking is there's a couple here, so we're going to particularly track the story from the perspective of the husband. And then, like the final bit is, you just align both of these. So you take the condensed plot points of what the story is like, you match it up with this neural co-reference model, and what you basically get is right. So, and then what you get is basically, you have this condensed story from the perspective of a single character within it. Okay, so now that you have this story, we're going to go back to this idea of soft causal relations. I'm going to show you exactly how we're going to generate stories using, causal common sense plot ordering. This is going to be known as the C2PO system. So the idea here is that now that you've got this like set of plots, we're going to generate a plot graph that sort of like fleshes out the rest of the story. So plot graphs are, these structures that have been like relatively well accepted as representations of story like progression. The main difference here is that traditionally these rely on hard causal relations, right? So the big idea here is, what if we could have the best of both worlds? So a plot graph that makes representing a story like very intuitive in this sort of like, step-by-step causal progression. But it's also easy to unroll and easy to sequentially generate because of this idea of soft causal relations. So let's see how we can do this from here. So plot generation using this has 3 main steps. So the first bit, the 3 main parts. So we're going to have a starting plot point. We're going to have the ending plot points. So these starting and ending plot points are from the big overall story that we've seen before. And then we're going to have a sort of like a bunch of intermediate links. So now these intermediate links are, they're generated using this transformer model called Comet. And Comet is basically just like, your standard autoregressive transformer. And it's trained on this large scale, crowdsourced common sense knowledge graph that's known as Atomic. So Atomic is really the sort of key here, in that Atomic has information regarding, what people find or like what people expect in various kinds of situations. So it's also, I guess, worth noting that we can replace this entire system by, just swapping out Comet and Atomic for, another common sense knowledge graph source, something like ConceptNet or whatever. Okay, so from here on out, there's what we're going to do is we're going to start from the sort of like starting plot point, and we're going to generate these like sort of intermediate links forward. So we're going to generate events forward based on the character's wants. So as you can see here, like an example of that is, here the first plot point is, the husband fears for her life, so he's presumably talking about his wife, and so what does a husband want to do now that like he's given this plot point? So two potential subsequent plot points after this are, he wants to get away and he wants to be safe, right? And then you can like, generate more plot points based on these subsequent plot points. So, he wants to escape, to be free, to not, be hurt, to avoid danger, so on and so forth. So we have this, this forward-facing graph that's based on the character's wants. And now that we have this, we move on to the next bit. So the next bit is we're going to basically repeat the process, but we're going to do this backwards from the last plot point. So from the last plot point is sort of like the target plot point that we want to get to. So in this case, the target plot point is, the husband scales the wall, right? And we're going to generate backwards based on the character's needs. So what exactly did the character need to do in order for them to, be able to scale the wall? Well, like, you can see here, right? So in order for the character to scale the wall, they first need to, go to the wall. They need to know how to scale the wall. They need to like learn how to like get up. And in order to learn how to scale the wall, they need to learn how to climb, so on and so forth, right? So this gives you sort of this like backward link. So now, given both of these together, so you have this forward like plot graph, you have this backward plot graph. So one is based on the character's wants, one is based on the character's needs. And so what we're going to do is we're basically going to link them together in this like almost dynamic programming style approach by basically ranking the best vertex in each of these like subgraphs. So like the forward subgraph to be connected to the backward subgraph, and in the backward subgraph to be connected into the forward subgraph. And we're going to do this, the details, more details are in the paper, but sort of the high level overview is these sort of like weights for doing this dynamic programming are calculated by the probabilities, that are generated by Comet of generating each of these like vertices subsequently, forward and backward. So sort of like the wants and the needs probabilities that are given to us by Comet. Okay, so we have a bunch of stories now. So what are we going to do with these stories? So it's time to actually like evaluate and see where we're going with this. So we've decided to, generate stories, in two genres, so mysteries and fairy tales. And we're going to compare them to two strong baselines. So we thought a lot about, how we're going to select the baselines for this. And we thought about really like, okay, so what is it exactly that C2PO brings to the table? So what C2PO brings to the table is it lets us do common sense reasoning within the bounds of something that's designed for storytelling. So it has this sort of like inductive bias of being able to structure plots while also doing, common sense reasoning. And of course, to compare that, across these two dimensions, we basically like drop one or the other out. So the first of these is basically, a transformer BERT-based baseline. So BERT plus infill is what it's called. So what we're really doing here is we're going to use BERT tuned in these sort of like genres to fill between the plot points. And so in terms of the two dimensions that I just talked about, the common sense and the plot structuring dimensions. So, there's been like a lot of work recently that's shown that, BERT has a lot of sort of like implicit common sense knowledge that's gained, via law of large text, as I like to call it. But the thing that it doesn't have is it's basically just like a masked language model, and so it's not particularly designed to do any sort of like explicit plot structuring, like C2PO does with the plot graphs. And the second of these is, a popular recent storytelling approach, the hierarchical fusion approach. And the gist of the idea here is that we're going to generate like this high-level plot first, and then sort of like lower-level plots from that. So as you can see, this is something that's actually particularly well-suited to the way we're doing things. The caveat here is that there is no real like common sense knowledge that this thing has. So it's really just trained on, just the stories. It doesn't have, the advantages of like, BERT or something like Comet of being trained, on like a large amount of text data or a large scale knowledge graph or something. But what it does have is it has this idea of plot structuring, basically because it is designed to, hierarchically generate, more and more elaborate plots. So what we did is, we generated stories in like each of these genres, for all of these three baselines. We gave them to people. So we had 350 something participants in total, and we asked the people to basically, answer some questions. So here are the questions that the people were answering. So they were mainly ranking these stories in across sort of like three metrics. So the first is that of coherence, right? So basically, which of these stories events occur in a more plausible order, which of them follows a better plot, whatever, right? Then the second is interestingness. So, which of the stories are more, higher quality, which are more enjoyable. And the final bit is, because we are doing this in a couple of different genres, we want to be able to talk about, okay, so how much does this story actually like resemble the genre that I gave to you, right? So like, does it actually resemble like a mystery? Does it actually resemble, a fairy tale? So here's some of the results. So first, this is the comparing, pairwise C2PO versus like the BERT plus infill. So recall that, C2PO has got both this like idea of common sense reasoning and plot structuring, and then the BERT plus infill has some common sense reasoning, but it's got no plot structuring. The first sort of thing to note here is the sort of differences in genres for performance. So what you're looking at is the percentage of people out of 100 that preferred one of these models as opposed to another when given two stories, right? So basically, the higher the percentage preference, the better. So based on that, we can see in terms of like coherence metrics, especially in the fairy tale genre, C2PO performs significantly better than BERT plus infill. Whereas like in mystery, things are a little bit more, I guess, like comparable. But on the other hand, in terms of like interestingness and, genre resemblance, C2PO manages to generate like a lot more interesting stories in the mystery genre as opposed to fairy tales. And of course, once again, this pairwise comparison, this time against the hierarchical fusion. So, recall the hierarchical fusion, doesn't really have common sense reasoning, but it does have a lot of like plot structuring. So the results in this case are, a lot closer actually than with BERT, than when we faced off against like BERT plus infill. But it is important to see that like on the whole, across both genres, so mystery and fairy tales, C2PO does fairly similarly in terms of coherence, but it does perform a little bit better in terms of sort of like genre resemblance and adhering to sort of like a single theme throughout things. Okay, so what can we learn from this, right? So like I just basically like explained the, all our results to you. So what we can learn from this is using common sense reasoning to exploit story structures in the form of plot graphs. It gives you sort of like more coherent, more interesting, and more thematically relevant stories. And also the perceptions of overall story quality depend on causal coherence, so especially in sort of like mundane genres, right? So Basically, the further thematic common sense diverges from everyday common sense. So, you know, fairy tales generally have like a lot more fantastical common sense knowledge than something like, you know, a mundane, you know, hard-boiled detective novel, right? So the more this happens, the less weight people place on the actual like causal coherence when looking at sort of like overall narrative quality. That's all. Thank you. So the paper and code can be found here. I can be reached at these locations.